In the previous video, we created two simple transformers that we're going to use for the rest of the course that take some parameters and then are able to transform data. What if we wanted to create transformers that are also able to learn and store parameters? In this video, I'm going to walk you through some examples of how we can do that. If, for example, we wanted to create an object that performs mean imputation, we can create the class Imputer that inherits the base estimator and transformer mixin from Scikit-Learn. In the init method, we can pass some variables. We can go ahead and check that the variables are a list, and if not, we can raise an error, and then we set the values to the class. Then we create the fit method that takes self, the data frame, and the option to take the target to make it compatible with the pipeline. And here we can persist the mean values in a dictionary with this line of code. The class is going to take the attribute Imputer dictionary, and this dictionary will contain the mean values for each one of the variables that were initialized when initializing the class. We take the data frame, just the variables of interest, we calculate the mean, and we return this in a dictionary. And this dictionary is stored in the Imputer dictionary. To then transform the data, we create the transform method that takes the data frame, creates a copy so that we don't override the data frame passed as argument. And then for each feature in self.variables, we fill the missing values with the value stored in the Imputer dict for that particular feature. And this method returns a new data frame with the missing data imputed. We can create a similar class for the rare label categorical encoder. It inherits again the base estimator and transformer mixin. In the initializing parameters, we can set the tolerance under which we will define a category as rare, and then the variables that can be entered as a parameter. We set these values to the class, and then in the fit method, we're going to create the encoder dictionary this time, and for each variable in self.variables, so for each variable in the ones that we want to encode, first we're going to determine the frequency of each one of the categories. We determine the frequency with value counts and normalize equals true. And then we're going to store in the dictionary for this particular variable, we are looping, a list of the categories with a frequency bigger than the tolerance that we also passed when we initialized the class. Now, to transform the data, the transform method takes the data frame, it will create a copy, and for each feature in the variables that we want to encode, it's going to replace the original value by this code here, and this code is identical to the one that we have in the notebook. If the feature value is within one of the frequent category lists for this particular variable that now is stored in the encoder dictionary, then we keep the original value, otherwise we replace the value by rare. Finally, we can also create a transformer for the categorical encoder, inheriting the same classes. This encoder will take as argument the variable to encode. In the fit method, we need to take the target because we're going to order the labels according to the mean of the target. So we concatenate the data and the target into a temporary data frame. We add target as part of the column names. We create again an encoder dictionary, at the moment empty. And now for each variable in the variables that we want to encode, we group the data by the variable, and then we determine the mean of the target. So in this case, what we're doing is determining the mean of the target per category of the variable. We sort these categories in an ascending order, and then we capture the index. This is what is contained in T. is the ordered name of the categories based on the target mean, and then we create the dictionary just like we did in the notebook. We create key value pairs for each value and key in enumerate T, so in the numbers contained in T, starting from 0. To transform the data, we just loop for feature in self.variables, map the feature with the mappings contained and stored in the encoder dictionary. We're not going to use these classes in the course. We're going to use instead the classes of the open source packages. But I wanted to give you a flavor of how you can make more complex classes if that's what you want. And if you want to learn more about this type of coding, one good way forward is to go around and browse the source code of the different available open source packages. That worked very well for me, at least. See you in the next video.